So now we're going to cover the last part of ionic compounds, and that deals with polyatomic ions. So let's talk about what are polyatomic ions. So polyatomic ions are single ions that contain more than one atom. Okay? So polyatomic ions are single ions that contain more than one atom. The name and charge of my polyatomic ion, they do not change. So polyatomic ions, they're going to have multiple atoms, but it's one thing, one ion, and that charge of that ion and the name of that ion doesn't change. So if we have a polyatomic ion in my compound, we name my ionic compound just the same way. So we name any ionic compound always the same way. We first by naming the cation, and so the cation could be an invariant metal, a variant metal, or a polyatomic ion. And if it's the polyatomic ion, it's just the name of the polyatomic ion. So we name the cation first, and then the anion, which the anion could either be a non-metal or it could be a polyatomic ion. All right, so let's look at a chart of polyatomic ions. So you've got this slide and the next slide are charts of polyatomic ions. So we only have 3 polyatomic cations, then we have this chart and this chart of all the anions. Now let's talk about this. Polyatom, multiple atoms. So we've got more than one atom, and they all have charges, okay? So polyatomic means multiple atoms, and it's an ion, okay? Polyatomic ions. Now here's the thing, you actually have to know, you need to memorize this chart and the very next chart. You have to know both of these charts for the polyatomic ions. However, I'm going to give you some helpful little guidelines as to how to remember them. So there's some patterns that you could find within these. If you notice, some of them end in 8, some of them end in ite, some have a per in front of them, some have a hypo in front of them. So we're going to talk about what these ites and eights and pers and hypos mean in regards to what these actually look like. Okay? All right, so first one, elements in the same column form similar polyatomic ions. And so when I say similar, it means the same number of oxygens, because most polyatomic ions actually have oxygen, and the same charge. So what I mean here is if we go over here, we have chlorate and chlorite, okay? But I have those with the chlorines here, but I don't have any of bromine. And if you've noticed, here, let me move that out the way. Chlorine and bromine are in the same column. So if I know what chlorine does, bromine should make the similar polyatomic ion. So here, if chlorate is ClO3, then bromate would be BrO3. If chlorite is ClO2 minus, bromite would be BrO2 minus. Okay, so similar patterns. So for example, ClO3 minus is chlorate. So if I change that and put the Br in there, now it is bromate. I could put an I in there because it's in the same, and it would be iodate. So if the elements are in the same column on the periodic table, they're going to form similar polyatomic ions. The next one, if the polyatomic ion starts with H, with hydrogen, then we're going to add hydrogen as a prefix before the name, and we add a +1 to the charge. So for example, and I'm just going to write it up here for space, and so it's easier for you to see. So if I have CO3 2-, that is carbonate. Now if I want to add a hydrogen, the name would change to hydrogen carbonate. That's how the name changes. I take the polyatomic ion and I just add the prefix, it's kind of like a prefix, to the name. So I add the word hydrogen to the name. Now to change the formula. To add the formula, I add an H to the polyatomic ion, but then I have to add a +1. So I need to add the H here and then a +1. So if it's a -2 and I add a +1, this is only going to be a -1. So that's the difference between these two. So carbonate, hydrogen carbonate, you add the hydrogen in the name, and then you add the H and you add a +1 to the charge. So that's what this is saying. All right, next, let's look at the endings and then those prefixes. So our base example is going to be an 8. An 8 ion is the base. So for example, chlorate is ClO3-. This is our base. Okay. Now, if I want to take the base, the 8 ion, and I want to add 1 oxygen. So I take my base and I add 1 oxygen. Now what happens is, not only do I physically add the oxygen in the formula, but I have to add the per prefix. So in our example, if I want to take my ClO3- and I want to add an oxygen, now it's ClO4-, so I add in an oxygen. To the name, I add the per, so this is perchlorate. Still has the 8 ending, but now the per tells me that it has 1 extra oxygen compared to the base. Now what if I took my base and I wanted to remove an oxygen? Now this is where I add the suffix -ite. So back to my example, if it's ClO3 is the base, now I want to remove an oxygen, so now it's ClO2. So I remove an oxygen, 1 less than the base, and so now instead of it being an 8, it's an -ite. So ites always have 1 less oxygen than 8s. So if you know the 8, you also have the -ite memorized. And the last thing I could do is I could take my 8, my base, and subtract 2 oxygens. I still have the suffix -ite, but I also now add the hypo prefix. Okay, so now I add the hypo prefix. So if it's ClO3 is my base, that's my 8, and I want to lose 2 oxygens, then it's just ClO-. And then to get the name, I go from 8 to -ite, and then no prefix to prefix. So hypochlorite. Prefix and the endings. So this gives you an idea of how they're all related. 8s always have more oxygens than ites. And then on the outsides, the most oxygens and the least, you're going to have prefixes, per for more and hypo for less. Okay? So if you know those patterns, it kind of helps you when you're looking at some of these charts and trying to figure it out. So here's an 8 and here's an ite. See, it has more and less. Here's when we see the words hydrogen added in like we talked about, those kind of things. So that's going to help you. You've got your pers here, so now that means it's going to have a different number. And then your hypo, less than, pers, more than, the base. You see it's eighths and it's ites. So all of that will help you in memorizing your polyatomic ions. So now in the next lecture video, now that we know what a polyatomic ion is, now we're going to start naming ionic compounds that have the minimum.